Hey, what's up guys? Samuel here. Today I'm going to show you guys how I make the pillar top. This is my first Kickstarter campaign. Let's get started. To start, you'll sketch your design. This is where you do it. You start with a blank page here. After you finish sketching your design, you'll end up with something like this. A lot of dimensions and your rough outline. Well, I say rough, it's because it's not a finished drawing at this point. This is where it all starts, is with a design and a drawing, and this is how I get my ideas out. From here, lots of times I'll 3D print my designs. They usually don't turn out very clean. The edges are rough, that kind of stuff. Like printing on the bottom, I have to have supports, and so it doesn't look the best, but it gives me an idea of the size and general shape of what it's going to look like, which really helps a lot. And the 3D print only takes usually around like 20 to 30 minutes, so it's not too long to have an actual finished prototype in your hand, instead of having to fully set up the machine, tune the program, get everything running well, all your tools offset, touched off properly. It's just a big process to do it in the machine versus throwing the design onto your SD card, plugging it in the printer, and push go. And 20 minutes later, you have a finished prototype. But this is the drawing. Here's a prototype I made in aluminum. Let's see if it'll focus. So this was after I had 3D printed it, was happy with the design, and decided this is what I want to go with. And so I moved on to machining and started in aluminum, and that's where I sort of tweak my feeds and speeds a little bit and get all my tools touched off properly and offset how I need them, and get the bearing pocket drilled to the exact depth I need. That needs a little bit of tuning, and kind of setting all that up. And once you get that set up, then I run it in brass and have a finished product. The knurling looks good. I need to tune this stem the way it's machined still, so that it makes the knurling process easier, but it's turning out very nice. It's working great. This is a finished top right here. And the same thing goes for the spin stations. It's the same process, with starting with a drawing, getting your design into 3D space on the software with Fusion, and 3D printing it. And the stations print fairly quickly also. I want to say it's about 25 minutes or so to print a station. It's not too bad. And the lens that it's using and that it spins on is a 50 millimeter concave lens. I want to say the like focal length is 150 millimeters. I forget. I'm pretty sure it is 150 millimeters. But these will be the spin stations that will be an add-on with the tops, the pillars. And I don't think I'll offer this color. I didn't add it in the project launch. This is just a color I have already on hand. I gotta order all the colors that I'll be offering. And once the campaign finishes, then I'll order everything. After you create your drawing and your design and you're happy with where it's at, next you move on to the manufacturing part, and this is creating your tool paths. So I always start with the facing. I'll kind of run through these really quick. I'm not going to take too much time with each of them, but first you face the front of the stock, rough it, finish it, rough the rest. So running with a right-handed tool, you'll see how it cuts this slope here, and it avoids all the actual shape because the tool can't reach that. So it's just going to cut as far as it can at this angle, clearing out all this material. And I do that a couple of times in order to make room. Here's the drilling. So I spot drill first and then drill the pocket. And then I come in with a left-handed tool, and that's the tool that I'll rough out this little like triangle spot of material, and then I'll use that same tool and finish all of this. And I had to cut this in steps to give clearance for this tool here. So it'll finish, and then same thing here. It roughs these out in steps, and then we'll finish the stem, and then the parting operation. So it'll part, and the way it does this, it'll part just down to this corner, and then it'll back out and it comes down and it'll chamfer that corner or that edge right there. And then as it chamfers, it'll part off the rest of the part. And I'm gonna run the simulation just to kind of give you guys an idea of how the tool paths work. I'm gonna speed it up. And so that'll basically tell me how exactly my tools are going to run and what I should be looking for when the machine's running. Sometimes weird things happen, the machine gets confused or whatever, code gets mixed up, and it doesn't always do exactly what you want or what it shows in the simulation. I'd say 99% of the time it does, but every once in a while I miss something, or I misclick, I accidentally do something that I don't catch, and I get like a weird tool path, or maybe I tell it to do something that I didn't think I was gonna do. And it's always good to run your simulations because it's an easy way to catch those mistakes rather than going out to the machine, running it, and then you find out when it's too late and your tool just slammed into the material. So the simulations are very helpful. After we finish programming, we'll come over and start the machine, and it's got a little startup procedure. I got to reference my Z-axis and my X-axis. You'll see the turret moving. It's got little sensors that it touches off on, and that's how it tells itself where exactly it's at. You have to do this so it basically finds its home. And once it finds its home, then it knows where it is in space. And now when you tell it to move somewhere, it knows where it's going. We'll go over to our programs, open up the pillar program, and it'll look very similar to how it did on Fusion. It'll show you all the tool paths here. And I can click on a tool path, and it'll bring me to that tool path in the program, so I know where it's at. If I need to make any sort of adjustment, it helps being able to click on that tool path where I was having the issues, find it, go to the program, and then be able to change it. So what I'm gonna do is we're gonna set up some material, and I'm gonna run a part, and I'm gonna make one. So to set up the material to the same length, it's tight. There we go. What I'll do is I have this cool tool called a stop lock. So we take this, and I'll set my distance with these, and it's just got a little set screw in there, and you can set any distance you want up to, I think it's 6 inches. Yeah, 6 inches. So I have that set there. I just take it with the material. I will, hold on, there. There's this little nub that's left when I part off the tool, and it's hitting on this spot right here of the stop lock. So I got to hold it down just a little bit to clear that. But once I line it up right where I want it, I'll lock it down in the chuck. And that's how I set my material consistently, and I get it the same every time. Now this is the cool part. The parts catcher is going to work. See if I can get you an angle. I think where I had you was better.
I finished pillar top.
Now, once I finish them, I'll run a few at a time, and I'll run them in the ultrasonic cleaner to get rid of all these little specks of loose material from the knurling. The knurling, all it's doing is just squeezing the material, and it smushes it between the wheels. And as it smushes it, it raises up the material into the high spots of the knurling wheels. And by doing that, it crunches off some material and it leaves all this flaky, fine little stuff. And so I run it in the ultrasonic cleaner and all that stuff falls off and they come out looking fresh and clean, just like new. And the last step, of course, is to press the bearing in. Focus. There. Oh, that might be a little light. I might have to press that a little more. There we go. Right at the halfway mark. Looks good.